Okay, we're live, we're live. Okay, attach your private rail car. Stripe laying out 14% of the workforce. Yeah, it's been a pretty rough day. Date me, Google Docs, and the hyper optimize. Nah. Twitter to start layoffs. Oof. Okay, well, it is interesting. We filed a lawsuit against GitHub Copilot. Wait, what? That relies on open source software piracy. Interesting. I told you that I teamed up with Amazing Class Action Law lawsuit. Interesting. Challenging the legality of Copilot. Okay. We contend that defendants have violated the legal rights of a vast number of creators who post code and work under certain open source licenses on GitHub. Okay. Interesting. Enumerated in the appendix to the complaints. Okay. In addition to violating the requirements of these licenses, we contend that the defendants have violated GitHub's own terms of service and privacy policies, forbid the removal of copyright management information, Consumer Private Act. Interesting. So they're saying that a lot of the way that GitHub uses and was able to work on Copilot was on open source software that was never meant to be commercialized. Okay. Hey Justin, what's up? How was the conference? Pretty good. I'm not gonna lie, my voice is a little bit weak right now, and I don't feel very much like talking that much. So probably after this stream, I'll probably shut it off, because I definitely need to rest my voice and shit. But I'll say like going like 8-10 hours talking to people and stuff, it's very draining. So I honestly don't know how streamers who stream for like 8 hours a day do it, constantly talking and shit. It's really really hard. So, but yeah, I think going to those conferences is super super interesting, and I would highly recommend that anyone who is interested in these sort of things really go about and try and talk to the people there. It's actually really hard to network at these conventions. So let me be specific. So I went to the Grado Productivity conference, which basically talks about developer productivity and setting up the tools for that, right? And so because it's like such a niche area that's only really been started in like 2016, 2017, there are only like a handful of developers in the world who can actually talk about these things. So what do I mean by it? When you're dealing with architecture at scale, you need someone to manage the architecture, right? And to make sure that developers who are your customers are going to remain productive with the standardized tooling that you've presented. So when you actually talk to them and you try and figure out the technical problems that they're dealing with, a lot of it is hyper optimizing for the tail risk of things. I'll give you an example. So suppose that you wanted to make sure that everyone's environment was exactly the same. You have two options, right? One is to have everyone run brew install on Mac OS, right? But then you might have some version conflicts. People are like freaking doing installing their own tooling and whatever that might require library bumps, and then that will destroy the standardized tools because you updated the dependencies that may or may not actually be working with the current recommended versions, right? And so because of that, you end up that's like a version of dependency hell. So how can you resolve that? How can you ensure standardized tooling for all the developers for your code base and whatnot? Well, you can create a remote execution environment, and LinkedIn does this as well. I think they recently had done it, where it's just like a Kubernetes and Docker image that has all the dependencies installed for you. But the problem that comes with that is that usually these images are Linux based, and most people don't really have good CLI or Linux understanding, and so being able to manage that is going to be very difficult because, well, how do you spend the time to educate and make the developers that you're servicing be fluent in both Mac and Linux environments? Not to mention, each one of the tools that you are using have to also have parity between Mac and Linux. So it's an additional environment that you're introducing to developers, and that you need to manage. But the benefit is that you standardize dependencies, and you also get the computing power of the cloud. So it's that trade off. You get the boost. So does that really boost productivity? Question to answer really, because now you have to start diving into technicals and how to reduce complexity of those technicals. It's a very niche field, and there's a lot of tail risk involved, but that's where the teams are needed. You just need to handle these one-off tail risks and systemize it, so make it systemic, make the fix you would make for those systemic and easily understandable. I think that's the best way I can describe it. So with that, let me bring on my client and see what's up.
Hello?
Hey, what up?
Uh, 1 second. Let me put this on my headphones.
Yeah.
Hello?
Hey, hello.
Hey,
Hey, how's it going?
good, good.
All right, cool. Yeah, did you get a chance to look at the problem from Tuesday?
I did the analysis and I tried it again. I got farther than last Tuesday.
Mm-hmm.
But yeah, there's still some things that I still want to work on, and I'm still kind of slow on these problems.
Mm-hmm.
So yeah, that's my main pet peeve. But I did manage to do it one thing at a time, right? Because there's so many moving parts and a lot of things you got to consider.
Mm-hmm.
So yeah, I try to do it more cleanly this time around after doing other problems as well.
Yeah. The key is that from last time, basically the mistake you made was make it more organized, make it your thoughts structured, and start from top down. Like, okay, this is the problem. The problem is composed of X, Y, Z, and then let me tackle X, Y, Z at the time, and then yeah. So I'm very curious. Like, what did you specifically do to address this? Like, what was changing in your thinking?
What's changing in my thing is not going back and forth between like idea and examples, right? Try to like have it more self-contained, right?
Mm-hmm.
Like if I'm talking about an idea, I'm gonna test it and explain that it works before moving on. Yeah.
Okay. Um, it can't just be that alone. The reason why, and I'll go back to a point I repeated on Tuesday, is that it needs to be fluid. It needs to be like a natural cadence, a natural tempo that you're moving at. And so sometimes it's necessary to go back and forth between ideas when you're testing and trying things out, right? But more importantly, is to be able to understand what the problem you're currently trying to solve is. Because, a problem is composed of a bunch of sub-problems, right? And so what's that sub-problem that you're trying to solve, and where is it going to take you? That's really the question that you need to really be able to answer at any point in time. So it's like if I figure out, like, let's say how to split up, the loops, right, of the sliding window is like what do I do in situation A, what do I do in situation B. But I know that if I handle situation A and B, that I can handle every single state that the problem can ever be in.
Okay.
Something like that. Like, what's the sub problem here, and how is what I'm doing going to get me closer to solving the problem?
Okay, so that's what you mean by when you say like what is your objective, right? Like your current objective at the time, right?
Mm-hmm.
Okay.
How is what I am currently doing going to get me closer to the answer?
Okay, that makes sense.
Yeah. And you're gonna be able to answer that. Unfortunately, this is the part where how to describe this? It's an instinct thing, right? It's like you've seen this structure of how to solve things before, and you're applying it to this problem, right? That's the best way I can describe it. Because at this point, it's instinct, right? I can tell you exactly what to think. I can tell you what you need to do, but for you to be able to make it natural is going to be take like how your mind works, right? I can put a sheet of music in front of you. I can tell you what notes to play. But in order for it to be music versus you punching the keyboard, there has to be some fluidity that binds it all together.
I see.
There has to be like some way you think about the code or the world or the problem that turns just notes into music. And whatever that's going to be for you to figure out. And unfortunately, I can only give you the feedback for what's wrong and what I think you should do. But then you have to make music. I think that's the best way to describe it.
Okay, that makes sense. Yeah.
Okay, so that did you do anything else other than the problem that other than the one on Tuesday?
Yeah. I did. Let me see. Yeah, I did some from the honors chapter. I did the rotate array problem, and I also did the justified text problem. So for the rotate array, I did manage to get that solution. I did it in 36 minutes looking at my Tyree. Yeah, I just wish I was a bit faster here. And for the justified text, let me see, justified text, that took me like 45 minutes, right? Because I was typing down the problem, right? So let's say 40 minutes. So for this one, I only got to idea. I didn't get to code. So yeah, it's just being slow there. But the thinking was structured if you look back at my problem log.
Okay, let's see.
The thinking is like structured, right? It's not going all over the place. So I just need to speed this up here.
Yeah, it's so row 185?
Let me see. 184.
184, okay. Yeah, let me see your, let me see exactly what you're doing here. Okay, no case on final line, spent a lot trying to understand. Yeah, that's fine. I get this part, that's fine. Stop myself fully understand the problem. I can respect this. That's fine. If you spend like 15 minutes trying to understand the problem, that's completely okay. Delta right logic. What book does a cleaner way? That just adds words until it cannot. Yep. Okay. Book did less variables. And use it. That just adds more complexity and more overhead. Had the right idea, but we output it. Okay. Big idea. Before I would get stuck on the example phase, not make progress. Good clean way to arrive at the idea. Okay, I'm curious. I want to. This is your delta, but I'm curious. I want to see your actual problem sheet. Do you have that?
Okay. Yes. The problem log. Let me send it over.
Yeah. Let me see. Like when you write it down.
Let me send it over on Zoom.
Okay.
It should be in, let me see. Page, let me see, where am I? Yeah, search for justified text.
Okay.
Page, looks like page 6. Let me see.
Got it. Okay, justified text. This is an EPI problem, right?
Yep.
Okay. Let me pull up the text. The problem is concerning with justifying text. It abstracts a problem arising in typesetting. The input is specified as a sequence of words, and the fuck. Fuck this. God damn it.
Yeah.
I hate this fucking shit. Just give me an example. God damn it. The quick brown fox jumped over the lazy dogs. Okay, and the line length is L. Then the return result should be the blank. Denotes a blank. Okay, wait, hold up. After justification, each individual line must begin with a word, and then subsequent word must be separated from prior words with at least one blank. If a line contains more than one word, it should not end in a blank. The sequence of blanks within each line should be as close to equal length as possible, with the longer blank of sequence of any. What?
Yeah, I'm like, what the hell is this?
Right program takes an array and computes the justification of a text. Okay. The triple space. Why triple space? The fuck?
Yeah, because they can't put brown there, so they just resort to only putting those words that fit in the line of length 11.
Oh god damn. Okay, I need to reread the problem. I'm sorry. It abstracts a problem arising in typesetting. Okay, typesetting. The input is specified as a sequence of words, and the target line length. Okay, you get a sequence of words and a target line length. Oh, I see. You want to fit as many of these words in the sentence in the line at up to a length of 11. Got it. And so the quick this is a sequence of 11 characters.
Mm-hmm.
And because you can't put brown in there because it would go over 11, then you just fill it in with spaces.
Mm-hmm.
Got it.
Sure.
Fuck. All right,
Yeah.
let's see. Input sequence of words. Target after each application. Okay, fine. Each word's sure. One use case. Okay, so you come with an exception. Last line uses single space separators with additional blanks at the end. Okay, yeah. If you run out of words, then you need to add a bunch of spaces at the end. Sure.
Mm-hmm.
Sure. 10 minutes an example makes more sense. Yeah. I think this is fine. 10 minutes an example on your own, just like trying to understand it. Okay, that's cool.
Yeah, I still didn't understand this in bold, so I was kind of like fumbled on that. So I was kind of hesitant to proceed without fully understanding what that meant there.
I think that you can probably get a little bit faster at understanding the example. Just
okay.
I think I would, based on what you just told me, I think you were trying to come up with example after example to really try to understand what exactly your answer should be. No. The answer should be what's my input, what's my expected output, and why is it my expected output. So the input in here, you saw me like kind of reading like, fuck, I don't get it, you know, and I tried rereading it as a series of phrases, right? The input, okay, is specified sequence of words and then target line length. After justification, each individual line must begin with a word, okay, that's your condition, and each subsequent word, okay, the subsequent words in that line must be separated from prior words with at least one blank, okay, and the lines, and then after that, I'll just basically read in phrases. That's the way I say it, just because like there's so much fucking text. But understanding what is the input, what is the output, what are the conditions on it, and why, that's basically the formula for understanding examples.
Okay.
And you might need like read it like twice or three times. The first time to get the idea, second time to really understand the details of it, and third time anything you might have missed. So, all right, that's fine. So I would recommend that you do that because in an actual interview, if you spend too much time on the example, you might piss off the interviewer.
Yeah, for sure.
So get to the objective very quickly, and I think really looking at like how you come up with how you understand the problem, and being more efficient at that will help you. So, okay.
For sure.
But yeah, I don't mind the fact that you spent as much time as you needed to understand the example, but it just needs to be a little bit more efficient. Okay, add one word, 2 words to the line, add n words to the line, repeat until you get length. Yes, okay, this is fine. So this is basically what you just described as a greedy algorithm. Try to add as many words as possible to a line until you hit 11, and then go back to, if you grab like 3 words and it went over 11, use the 2 words and then fill in with spaces in between. Okay, that's fine. I have no problem with that. I think this should have taken you like 3 minutes to describe, actually. If I were to look at your replay, I don't know if you recorded.
Yeah, it was fast. Yeah.
Good. This is inefficient. Trying all possibilities. Yes. Add one more at a time and keep track of how many spaces will be in between. Yeah, space in between words. Line length minus length of word. Yes. So instead of counting up, you count down from 11, and then the moment you look at the next word and then check length. Okay, fine. Yes, invalid. That's fine. This is fine. Test. That's fine. Interesting. Got the idea in testing in 55 minutes. Here's the interesting part. This is not really any more different than what you just described for your naive solution, right? Instead of you trying to count up, all you did was a conditional and count down. My question is, why did this take 55 minutes? This should have only taken you this should have only taken you like 15 or 10.
For that, I spent a lot of time like trying to understand like the minimum space required. I was doing a bunch of example after example, right?
Oh shit.
And I think that had to do with not me understanding that statement in bold. So I think that kind of held me back there.
This one, the minimum space is required?
No, the one that's up here, where it says should be close to equal length as possible with longer blank sequences, if any, appearing at the initial part of the line.
Okay, sequence of blanks in each line should be as close as equal length as possible. Interesting. This one is too vague in my opinion.
Yeah,
What is?
I
What do you
think
mean
what
close? Yeah, go ahead.
I think I could have asked more clarity if the interview asked me this. He would have probably just said, "Oh, you're probably spending too much of this. Just to look at the example, right?"
I would say he just get the simple example working of like, hey, just get the naive solution where you iterate through the words and then just grab the words as many as possible,
Okay,
then you would have then you would have optimized for this. Keep in mind, you want to get the simple idea down, make it bulletproof, then optimize on top of it.
correct.
So for me, when I look at this and I see you get hung up on this, I see you're getting like distracted by something too complex. This is too vague.
Exactly.
I would have just gone straight ahead with with the naive and optimal thing I said, and I just would have just said this is too hard. There's too many conditions. I can't handle this. I'm gonna get the right idea first down, and then let me add this condition on top.
Okay.
One idea. This is a one idea at the time. This is what I call, this is the making music part versus being mechanical. You think, oh, I need to handle each and every single one of these conditions in order to solve the problem. Yeah, that's mechanical. The music part is let me do it one at a time because I'm not smart enough to handle all these conditions at once because I'm human. That's the music.
Okay.
So let me see what they say. Let me see what the book says. That requires look ahead. Yeah, that's not that hard. The number of spaces between words cannot be computed to a complete set of words of line that's known. Yeah. So okay, so you iterate through this, and then you look number of current words in the current line. Yeah. So look ahead length is the current length plus the next plus the current line length plus whatever word you're looking at, right? And if the current word you're looking at, you add join line with it. You add line, add the current. Yeah, this is actually very simple. This is the simple example actually. So you got distracted. In this case, this is distraction.
Yeah, exactly.
You got distracted. This is what I mean. Yeah. In an interview, yeah, you're right. You might have gotten called out for that. Just hey, just solve the example. But then, yeah, these problems are not meant to be hard. These problems are supposed to be like solvable in a logical manner. And it's up to you to admit, hey, this is too many conditions to handle right now. Let me get a simple answer down.
Okay.
I think that this is just you not recognizing your own limits as a human. Even I have limits. I even said, fuck, I can't do that. Just know when to say, fuck, I can't. I'm not that brilliant. I'm not that smart.
Yeah. So, and this being in the honors chapter is like, oh shit, what? These guys are probably looking for something tricky or what the hell, man. So, yeah.
There's a good saying. There's a fine line between sophistication and bullshit. It's like, the people who get in trouble with like, managing Wall Street money and shit, they just like over leverage on a bunch of fucking credit derivatives, and because they think, oh yeah, I can I can fucking make this like really weird optimization in this really weird place for this one specific situation and leverage the hell out of it. The answer is almost always, well, there's usually it's just two things, right? One, what if you're wrong? Do you blow up? Second one is, well, what if, like, not just if you're wrong, but what is the penalty? Like, what's the penalty if you're wrong? But then also, like, is there a simpler way to model this? I'll tell you a story just like before we get to the problem. There's a thing back in like 1987, Black Monday, right, where people invent like this idea of portfolio insurance, where all it was like you sell out of a market when it's going down, and then you buy back in at the exact same price when it goes back up. So that way, like in theory, what you would get is all the upside of the market moving up, but then none of the downs, and then you would you would like not get any of the losses when the market went down because you would have sold out, right? And that sounds great and all, and they invented some very, very interesting and funny mathematical formulas around it, and then it became a whole entire industry, when fundamentally all they did was, like, it's just a stop-loss order, right? It's like, oh, when the price goes down, sell. That's it. Like, it's a very fundamental idea, but why do you call it portfolio insurance and then systemize it? And so it's like, so what happened, and also it's a composite fallacy, right? What happens if everybody does it at the exact same time? Well, then you crash in a single fucking day. So you get some very funny things when people get too sophisticated. So almost always, if you just think of it in terms of common sense and just say, hey, it's not obvious to me, it's not punching me between the eyes, and I'm not smart enough for this, just solve the problem that you have right in front of you. That's it.
Okay.
Anyway, so that's my old man story. Fuck, I'm not that old. Fuck, I'm 29. God damn it. I'm talking like an old goddamn man though. All right, all right. Anyway, let's do a system design problem. Okay, so let's do the problem sheet, I think. Yeah. Okay, let me get out the timer. Okay, cool. Okay.
Are you in the prep doc?
I'm in the problem sheet, or do you want me? I'm in the problem sheet.
Problem sheet. Let's see. Okay, I see it.
You see this?
Yep, I see it.
Okay, cool. And then here we go. Just start the timer. Design a CI/CD pipeline system. Pretty simple.
Okay, so for this, you want Excalibur or just do it here?
We can do Excalibur if you feel more comfortable with that.
Okay, sure.
Okay, let's do Excalibur. I'll give you the link. Give me a second. Start session. I'll paste it in Zoom.
Okay.
All right, cool. You in?
Yep.
Great.
Let me add some assets here.
Okay, yeah. Set yourself up.
System design. It's not loading. Let's see. Yeah, let me just add it to another browser in a second. Okay. Okay, so I'm in now. So
All right.
okay, so designing continuous integration, continuous deployment pipeline, right? So what does that mean? That's this continuous integration, continuous deployment, right? So it's gonna run runs your test, right?
Sure.
Deploys code. What else? Okay, so I'm trying to figure out exactly what this provides you, right? It's gonna run tests, right? Continuous integration, run test against a code base, right? Deploys code to machines on the web, right? What else? So one thing to note is what is the most important thing, right? What is the most important thing? And that is going to be my framework, right?
What do you mean?
Like my continuous integration, continuous deployment. That's the most important thing, right?
You're I'm actually not quite. I still don't understand what you're talking about.
So this is like who is my target audience, right? Like who is this built for, right?
Okay, who is So who is this built for? These are going to be this entire system is going to be built for developers at the company, right? So think of like Facebook, Google, whatever. We need whenever someone submits some code change, right? How do we know that this is going? We need to do like some preliminary tests on whether or not this works or not before we merge it in. So your job is to be able to handle as many of the responsibilities as needed.
Okay. So primary users, that's developers and DevOps, right?
Sure.
Because a developer will push code and trigger a job, right?
Sure.
A job. This can include tests. It can include deployment, right?
Okay.
Who else? DevOps. Um, they set up machines in the CI/CD framework, right?
Mm-hmm.
So what I'm doing now is I'm basically scoping this, like who are my users, what are my user stories. So from the developer standpoint, you push code, you trigger a job, right? That can either be a test or a deployment. Developer will push code and trigger a job, right? Jobs can be retried, right?
Okay, sure.
Jobs can be retried. The reason why I say that is when you trigger the continuous testing pipeline, right? You're gonna have hundreds of tests, 200s of tests, right? What if it's only one test that's failing, right? So you want the ability of jobs to be retried, right?
Okay.
Okay. Let's see. So. Okay. So yeah. I can retry my jobs. I can view output.
Yep. Like what's the result of that? Sure.
What else? View output. Okay. Yeah. Just from the standpoint of the developer, that's all I can see doing, right? You retry, then it's like the output, of course, is gonna see if it passed or failed, right?
Mm-hmm.
Passed or failed. Okay. What else? The jobs can be part of a pipeline, right? So a pipeline is a collection of jobs for the pipeline to be successful. All jobs inside should pass.
Sure.
Right? Okay. Okay. This pipeline should have a webhook back to your version control system, right? Like Git or GitLab, right?
Mm-hmm.
Okay. And this webhook should let me see. The webhook should have let's say we have an API for retry and viewing the status, right? Okay. So, okay, from the developer standpoint, that's what I have, right?
Sure.
I have a pipeline. It has a collection of jobs. For the jobs to be successful, for the pipeline to be successful, all jobs should pass. Okay, it's pretty standard. Webhook back to your VCS version control system, GitLab, or okay. And then there's an API, right? That the pipeline should have. Not the pipeline, or actually the API should be part of the CI/CD system, right? Not just for the pipeline. The jobs, okay, specific jobs you can retry, right? You can view the output. Also, give it a set of tests to run, right?
Yeah, sure. Or tests in general. Test is just one thing, but yeah.
Okay, or conditions or code to execute, right?
Yeah.
Okay. Yeah. So now I'm going back. Like I cover most of the cases for the developers and triggering testing pipelines.
Sure.
Now I have to consider the case of deploying code, right?
Let's start with this for now. Let's just handle this for now because fundamentally CD is really just another job, right?
Okay.
It's like if I want to build a binary and cut it, it's just really different flavor. So.
Okay.
Yeah, let's just handle this one for now.
Okay, sure. Okay. Okay, so let's say, okay, so I got my requirements down, right? Now now the non-functional requirements, right? That is okay. Should be stable and robust, right? We want maximum uptime.
Mm-hmm.
As far as so now I'm thinking of like I'm thinking of what I want, right? Like now I have to also think of what I don't want. I don't want the system to crash, right? That's saying it's stable and robust.
Yeah, pretty obviously.
I want. Huh?
Yeah.
Sorry, go ahead.
Yeah, I said pretty obviously. Yeah, you don't want things to break.
Yeah. Stable and robust. We want maximum uptime. What else we don't want? We have to monitor somehow. What, right? Monitor. Monitor the system, right?
Okay.
Obviously. Thinking back here, there's, yeah, I'm trying to see how like, I'm trying to see like I'm trying to see how to grow the system, right? That's what I'm thinking about. Right? How to
You
grow
think
the
about
system,
growing
right?
the system? Okay. Well,
not.
I don't understand growing because you still don't have a system just yet.
Yeah. What I mean by that is like what is most important, right? Like
Yes.
You have your read-write ratio, right? This is gonna matter. This is gonna decide how many machines you have, how many databases you have, right?
Sure.
Let's say like my read-write ratio, right?
Well, what data are you reading? What data are you writing? Let's start there. And where are you doing this? And what exactly are you reading and writing?
Okay, thinking back from my users, being the developers and the DevOps, right? Okay, yeah, this, like, yeah, because like a developer can trigger a job, right? That would be a quick write onto a database, right? But then that's gonna account for a lot of activity in the background.
Okay, well, when you say background, what exactly is in the background?
What's in the background is all the various tests that are gonna run for that specific pipeline, right?
Well, it's not necessarily in the background. It's the pipeline actually running, though, right? So.
Yeah, that makes sense. Okay.
Okay, yeah, so why don't you do this? Why don't you try getting like a simple design on paper and then expanding it out, see what happens.
Okay, so my end users. Yep, let's say I have a user here. I have my system here. This is my CI CD, right?
Mm-hmm.
Okay, this is gonna, let's say we just have a database, right? That stores, the database has, like, for example, job information, right? It has job information that has, like, the code to run. It has a code to run, right? I have a job, right? But I need some sort of job instance that's going to be based on this, right? Like, because this job can be triggered multiple times, right? So let's separate that out and call it a job instance. It's going to be a foreign key to the job, right?
Uh-huh. And
this can have, for example, the retry capability. It can have your output. It can have how long it ran, for example, start time and end time.
Sure.
What else?
So you have job, and then you have job. These are your database. Okay.
These are just relations right now.
Sure.
I also need the pipeline, right?
Mm-hmm.
A pipeline. and that has the order of jobs to run, right?
Sure.
And then I also have like the pipeline.
This is starting to get a little bit complicated because pipeline is composed of jobs, sure, and then each job has a job instance. I'm starting to think this starting to smell a little bit complicated.
Okay.
But I don't. But feel free to keep going.
Okay. Let me think about this some more.
Yeah. Try to get us something simple first.
Okay. Okay. So the user is gonna request the user, let's say they submit a pull request, right? The pull request is gonna send an API call to your CI/CD instance, right?
Mm-hmm.
That instance is gonna look inside into the database, and it's gonna trigger that specific job. Like for example, if I submit a pull request to my branch master, it's gonna kick off a pipeline that's gonna run all the tests that are supposed to run against this branch on your code base, right?
Okay.
I also have to maintain some sort of status, right?
Sure.
So I can let the user know when the job is done or what is the status of the pipeline, right?
Mm-hmm.
Yeah. So on paper, a user hits this CI/CD instance.
Okay.
That instance is gonna fetch all the job information for this job to run and kick off various tests.
Sure.
Which are composed of a pipeline, right?
Sure.
So let's say it just runs in this instance, right? Let's say right now it just runs in your CI/CD instance, right? But a thing with that is it's not gonna scale out as users, as your team is growing, as you're selling this product to more companies, right?
Sure, but what you've just said is you're hitting the CI/CD, but usually people are pushing, code pipelines and whatever, or code pushes. So I'm a little bit confused here. Like, you're treating this like a web server, I think.
Okay.
Like a website or something. I don't know. So I'm not really following. Well, you haven't really solved the case of what you just described, right? If the user's pushing code and there's a webhook to trigger a pipeline, you still haven't really solved for that case. At least it's not clear to me that you have.
Okay, that makes sense. Yeah, let me clear that up here. Yeah, so a user is gonna submit code to like GitHub, right, and submit a pull request to master.
Sure.
That should not directly trigger the CI/CD. What's gonna happen is I'm gonna have to hit this user submits code to let's say this is GitLab, right?
Okay.
GitLab is then gonna send a API call to your CI/CD runner.
Sure.
To kick off the test, right?
Uh-huh.
So yeah, the point of contact that contacts your CI/CD is gonna be a service like GitLab, right?
Mm-hmm.
Or if the user wants to host this themselves, they can call this from their own web server, right? So GitLab or a web server, right?
Okay. Yeah, sure.
Right. So what's going to happen, right? As this grows, right? You have more users, you have more API calls, right?
Okay.
You can't afford to keep running the pipelines in this instance here, right?
Okay. Okay. So you're gonna keep sending requests, but you're saying you can't keep running instances. Wait, what?
Sorry. I can't keep running the pipelines, right? because this consists of grabbing a bunch of code from your database and running it in some sort of machine, right? So my first,
Okay.
uh-huh.
Okay, keep going.
My first my very simple design was to run it in this machine here
Okay.
in a separate thread, for example. You just run like some code, right? So
Okay.
what I want to do is I want to have a separate instance that is going to be dedicated to running code, right? Or running your jobs. The reason for that is this single instance is not going to handle all the jobs as your system grows, right?
Okay.
So I want some sort of a job runner, right? Whether this is a queue or it can be separate boxes, right? Separate VMs that just run code.
Sure. Okay.
So let's say I add a job runner, right?
Okay.
Okay. So this job runner is going to be responsible for running your pipeline, right?
Sure.
No, sorry, I should name this pipeline, right? Because that's what you're running, right?
Okay. So what's the okay? So sure, you're running you're technically going through a pipeline. Why not? Sure.
So these are just going to be machines where I run code, right? So the CDI/CD instance is going to grab all that information from the database, right? This pipeline is then gonna grab that data and it's gonna run it. It's gonna run it in some sort of machine, right? In a machine.
Okay. Sure.
So I'm trying. So here now I'm determining like the direction of this, right?
Okay.
You're gonna grab a bunch of job information from the database, right? And what to run.
Okay.
So once that is completed, this information is then going to get sent back to the database, and it's going to tell you the status of the pipeline, right? And it's going to have like, for example, console log output for each job instance, right?
Okay.
So okay, so yeah, another inefficient that I see here is like there's too much stuff in this database, right?
Okay.
So I'm thinking here now. Okay, so going back to my functional requirements, let me see. Developer will push code and trigger a job, the test, or the deployment, right?
Okay.
And pipeline is all it is a collection of jobs for the pipeline to be successful. All jobs inside should pass. There's going to be various webhooks, right? There's going to be an API for retry. Okay, so I primarily handle the case of doing tests, right? But what about deployments, right? Deployments are going to hit the same path, right? Like this really depends. This really depends how you have it set up, right? Like
so
let's suppose for the
right, you're in control of how it's set up, so.
Mm-hmm. So let's say there's a trigger in GitLab that can deploy your code, right?
Okay.
So that's going to go through the CI/CD instance. There's going to be a pipeline to deploy, right? And it has an order of jobs to run.
Okay.
That pipeline runner is going to run. It's going to run, right? It's going to run your pipeline. but the thing that I'm missing here is like this pipeline runner. It can have different code, right? It can have various. It can have Okay, so the thing about this is like a pipeline runner, right? You should also handle like deploying your code, running tests, right?
Okay.
So the gap I'm missing here is like how you would run this and deploy your code, right? Um,
Why not just do a git checkout?
right. That makes sense. The next step for that is like how you deploy to like your machines like on Amazon,
Well,
right?
not even the next. That you're jumping way too far ahead. Let me throw something at you. What happens if these machines fail while the job is running? You know, maybe power goes out. Maybe hard disk dies or some shit.
Mm-hmm.
How are you gonna handle that?
Okay, yep. Okay, so I only have single instances of like the CI in the database, right? So something happens, this is gonna crash, right? You're not gonna be able to recover, right,
Mm-hmm.
from this.
Okay.
So my first step is to add a secondary or replicas to this, right?
Okay, so you're adding replicas to handle a power failure. Okay, sure. But
Mm-hmm.
how exactly how does that help you?
This helps me because this is going to be like a standby replica, right?
Okay.
If one of them goes down, the other one can take over, right?
Sure.
You also don't want to save it in the same data center, right?
I think that's less of a concern because if an entire data center goes down, you should have some way to handle it anywhere else. So it doesn't. The data center thing is not really it's not really as much as a concern as you think because you can always replicate it somewhere else. So.
Okay, so for power failure, okay, so you have, yeah, so I'm thinking, yeah, that's a good point there. Okay, so you essentially want to guarantee that against your machines going down, right?
Sure.
When, what can I do to recover fast, right?
Mm-hmm.
Okay, so if I have various copies of my database, right? Okay, so the first thing is to maintain multiple copies of your database, right, as backup. For the CI/CD instance, have multiple instances running, right? Since it's stateless, right? Because so I'm looking at the CI/CD instance, right? All it is it's grabbing a job from a database and it's sending it off to the pipeline, right? There's really no state there, so I can put multiple of these instances here, right?
Okay.
Okay, so to handle that load, I would just put a load balancer in front of this.
Wait, so how exactly do you say you're gonna pass it off to another runner in the case of failure? So, okay, in the end, low balance. Okay. So then you're going to have multiple servers talking to multiple databases.
I see. Yeah, that goes into the too hard territory there.
Maybe,
Or
maybe
too
not. I
complex.
actually you do some math and try to think about like what's going to go on here. Because I'm not entirely convinced that this really works. I mean, I get where you're trying to go at, but I could also be me trying to put pieces in for you. So I'd rather you lead this discussion.
Mm-hmm.
I'll give you 2 minutes and then I'll give you my feedback. But I think I think I've already enough to talk about.
Okay. Yeah, man. With the load balancer, and then you have multiple instances in front. Is like, how are you going to handle that complexity, right?
Mm-hmm.
Like, how are you going to retry a job, right?
Mm-hmm.
If you hit this from GitLab again,
Mm-hmm.
How are you going to know that a job failed? So this doesn't make sense right away, or it doesn't make sense to me. So
okay.
Yeah. So as far as the case of retrying a job, right?
Okay.
Okay, so the pipe, if I go through a user story, coming from GitLab, it hits your CI/CD instance, it grabs the information from the database, and then it kicks off a job runner, right?
Mm-hmm.
So let's say that job fails. That job failure is gonna send back a signal, right? It's gonna have to send back a API call of some sort to GitLab, right? Indicating the job status and what happened with the pipeline, right?
Sure.
So the thing I'm missing here is sending back information to GitLab, right?
Sure.
Yeah. So for that, let's say we save all that information to the database, right?
Okay.
The database is then going to send back a, let's say I have a, let's call it a callback service, right?
Okay.
Yep. So this is gonna grab the job and pipeline information from the database, right?
Mm-hmm.
And then it's gonna send it back to the user that called this pipeline, right? Yeah. So.
Okay. Let's pause it here because it's 30 minutes. All right. What did you think you did right? What did you think you did wrong?
What I did wrong is I really had no, like in the beginning, I was trying to figure out who my driving users were, right? Because I recognize that I made this mistake in the past with the cron job system design problem, where I was trying to tie this problem to users, right? And users connecting to like a social media website, right? So after that, for me, it was hard to pinpoint the pieces or tie everything together, or how to glue all this together and how I would handle all the retries and kicking off a service, right? So yeah, it's basically no direction. That's my big thing here.
Yeah, the reason why you had no direction is because you never solved the problem. You just kept trying to slap on shit and hope it worked. What I saw was you solved part of the problem, and then you tried scaling it out immediately without seeing it end to end. And so because of that, you kept trying to fire from the hip and hope that some scaling out effort would work. And I think we've talked about this in the past. Start with something simple that works, and then scale out each dimension based on the inefficiency. So instead of me trying to do this abstractly, let me actually show you how I would do it. I'll take your spot from, like, let's say that this was my requirements. I'll just go straight by the fucking requirements you gave me, right? So, and maybe this will do something. So, right? So, let me start the timer. I'll see how far I get in 10 minutes, because honestly, I'm not really quite sure. So, let's see. So, I'm going to start with something simple, right? I'm going to start with the end user. End user is going to push some code to GitLab. He's gonna push some. Yeah, let's use this. Push some code to GitLab. GitLab's gonna make a call to our server, right? And so our server is basically, yes, our server is just basically an orchestrator, pretty much. And in a very simple case, let's say that, one repo, one set of dependencies, and we're only going to use it like for a very simple case. Server is going to find some kind of agent, or let's say machine to run the code on, right? He's gonna take that diff of whatever code changes that he's got going. So let's just say diff or whatever, and that machine diff information info/pipeline to run, and then the machine will run that shit and then send back the results. Eventually, it'll send back the results somehow, right? Like, let's take a very, very naive approach. It will just like send it back to the server orchestrator sends it back to GitLab. The problem now is, well, what happens if the machine dies, et cetera, et cetera. What's our failover? So instead, what we can do is let's suppose that the machine dies, we can restart it, right? So let's do a database here. A database is just going to consist of the job that ran. So it's going to be let's say our jobs database, right? And the schema will be, let's just say the, what's it called? Let's say that we require everybody to push to a branch before it is merged in, because we need to be able to save the diff state somehow. We can't just like upload the diff necessarily. I mean, we could write it out, but I think it's just easier for us to write the change to a branch. So in other words, by the time our server orchestrator will actually have, let's say this. Let's say it will write the diff to a branch, and then this will, say pass along the branch to run on, and then /pipeline, right? So let's just say this job each job will have a branch and a pipeline to run, right? Fundamentally, a pipeline is just a series of steps. So, for now, let's just say the pipeline is just a script inside the database, or sorry, I say script inside of the repo. For now, let's keep it very, very simple. So, in other words, and then we'll also have like the status. We'll also have the status of it. Status, whether it's like started, running, and then success, fail. Let's keep this, right? And then jobs database will have this. So the machine will have the branch of the pipeline to run, and maybe even let's say the job ID. Because fundamentally, if you have the job ID here, you can get the branch pipeline and everything. So now we can evolve it. So instead of having to do this, we'd write the diff to the branch and then sends the job ID, and it creates the job ID. Yeah, the server will then create the job ID here. Write it out here. Job ID will have all this, and the machine just says, hey, I need to run job ID. Let me check out this branch and run this script. So far that will handle all that shit, and then by the time it is done, so we can just have like in a very simple case, we will poll every minute, and then report back to GitLab whatever has been succeeded. Something very simple, right? We'll report this shit back. Mm-hmm. And so now after that, it's like, okay, well, we also want to have some nice stuff, like putting out, let's say, the output of the job itself, like some logs. And then we can also pass that back, right? So, and okay, this is like 4 minutes of work. I've solved a very simple case where a single user has like a machine will then get the job from the database, and in case the machine dies, the server can just like restart the machine and get a new machine, right? So now we have this. We can just now start scaling out the number of machines that we have. Mm-hmm. And so with job ID will then change status each time. And then let's say, how do I know whether to restart a job? So we need to also say like which job ID. The job needs to also be like, if it is like, say, running, what machine is assigned to it, and so so every single minute, let's say, the server will query for all the jobs that are running, and then query each one of the machines. The moment that machine dies, let's say the machine's like unresponsive or whatever, and says, oh yeah, I don't exist, or whatever the fuck happened, or then it will actually, or like, let's say the hard disk failed, like in our failure case. So in other words, if fail, have fail error code for different errors, and like disk, memory, etc. Like if the machine's non-responsive, then we will go ahead and restart the job ID to another machine and then rewrite that.
Okay.
So that's basically how a very 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 simple system would go. So let's talk about some more complex cases, right? Let's say that we have developers around the world, right, who are going to be jamming on this shit. Then in this case, we would need to have like a job database replication. So let's say that this one is in, I don't know, Seattle, and let's say this one is in China, just for extreme examples. So in other words, these machines and data centers there's going to be like some kind of replication going on. So let's say this is like replicated. Replication every, I don't know, let's say 30 seconds. So, okay, the question now becomes, all right, well, why every 30 seconds? Because, well, how many jobs are we really running? Well, if you look at like all this shit, the only thing we really need to replicate is like that is critical is the jobs that are running. And then some of the jobs, we might be able to get away with not sending the logs over, depending on how large these logs are. And of course, this is where like calculations come in. Mm-hmm. But for the most part, all these information that I provided is not very heavyweight. So I'm going to say that we can definitely be replicate every 5 seconds or so. Let's do a back the envelope estimation. Branch name, not much. Pipeline to run is just a name, right? So all we really need to do is, in the worst case scenario, copy what the steps are in that pipeline. So let's run a file. So let's say it's a megabyte. Status, not much. Output of the job, let's say 50 megabytes. So in other words, it's basically the number of machines times 50 megabytes. So in other words, replication each way. So the math on that, so throughput is going to be 50 megabytes. At the worst, this is like worst case conservative scenario times number of machines per per center. And so you can reverse engineer it by saying, okay, we support, let's say 10 gigabytes per second transfer. You can say basically, okay, we can have like 2,000 machines per or 20,000 machines per center. Let's say 2,000. So basically, just in this fucking math alone, we now have like some kind of limitation on the number of machines that we can have. So okay, so we have 2,000 machines. 2,000 machines are going to be writing to the database. Now, is that going to cause a bottleneck on the database? It might. It might. In the worst case scenario, you also have like developer. What the next thing would be like if we scale that number of users, and there'll be like peak times when everything gets run and whatnot. In working hours, there'll be a lot of people using it. At low hours, there will not be a lot of people using it. So scaling the infrastructure to peak and non-peak user hours. Amazon EC2 does this very well, but in some cases, we might want to take costs into account as well. And so if we manage things on-prem, we can save like 1/10 the cost of Amazon instances, especially at this scale. If we're maxing out our throughput, that is. This is basically what I'm going to do. So then now, like, okay, the other thing is that if we just keep jamming the server orchestrator, then we're going to need to be able to start scaling out our servers themselves. And this will all be, this is where we start putting the load balancer in front. On top of that, and then if we're constantly writing to the same database that has the branch, because this needs to live in a repo, right? So the server itself can also have, we need to put it in we need to put it in the let's call this the repository. I think Git repos will be fine. I think just having some external Git service, because fundamentally all you're doing is just creating branches and diffs, and these can be parallelized. You're not necessarily sharing branches, and if you are sharing branches, it's gonna be one machine at a time, because every single diff is gonna have its own branch. I think the checking out a branch, it just depends on the diff sizes. At this point, it's gonna be like the size of these diffs that's gonna jam it. So like for instance, let's suppose that you're checking out, you made like 100 gigabyte change. Well, let's actually those changes should not be really allowed. So let's ignore that for now. We'll come back to it later. But yeah, I think this is gonna be 10 minutes of work. And I'll have 9 minutes of work, and all I've really done is just like handle the really simple cases. But I think that this really, this is basically how you should at least start off the problem, actually. But notice, like, I think I made more progress than you did, and a lot clearer.
Yeah, more.
So in other words, all I did was just say, hey, what's a simple case? Let me solve the simple case, and then like think about what can go wrong. In this case, what happens if the machine fails? Oh yeah, let me write down the job ID to the jobs. And I even started off with the, hey, let's just send the diff itself. And then I realized, hey, wait, we're gonna need to send more than that, and recover it. So then we use the job ID to stress that one out, right? And I can scale this out to see like, oh well, what if we want to put the jobs separately in a different repo or whatever, and we can do that. We can just, instead of having a output, what's it called, the script inside the repo, we could have a pipeline ID, and with a version, and then have that in a separate database. But like, I notice all these estimations. I don't think I veered too far from your thing. So in other words, now if I want to run tests, I can just say, okay, well, the script, a test is just really a run Java, compile a test, and run it.
Correct.
And then based on this error code or output of the job, I just feed that back to GitLab, and then just say, hey, this is like exit code 10, -1, whatever. And then GitLab will interpret that and block it. So it's just that. It's really being able to separate the responsibilities and being able to start simple. I think that's something you forgot, and I'm kind of seeing it multiple times right now, is that you forgot the idea of simplicity. You forgot the idea of just start simple, start getting shit done, and then scale that shit out once you're ready.
Okay.
Solve the problem in front of you, and then try to figure out what can go wrong. And again, with this, how do you know you've got it simple enough? When it becomes too fucking hard to take on any more conditions.
Okay.
All right. That's my feedback to you. But I think I'm judging from what I saw in your data structure and algorithms and system design, you really need to know when you need to get something down on paper, and it's the moment when it's like, oh fuck, I can't see the end to end of this.
I see. Okay.
So that's my feedback to you. I think if you can get past that, I think you'll be able to do pretty well on these. So.
Okay.
Any final thoughts?
No, man. I'm just gonna hammer at these again.
Okay.
Yeah, man. So I'm gonna go over all these problems again and revise the checklist too. Just make sure you don't forget that simple case.
Yeah.
Yeah.
It's really a simple case. Solve the problem in front of you, and then grow the problem. Like I can't even fucking tell. Like I didn't bite off more than I could chew. I just started with something very simple: one user, one machine, and just like make it run for me automatically.
Yeah, I think the moment when I started to go down was when I started talking about pipelines and the structure there.
Yeah.
I think I just started too complex, similar to the data structure problem, right?
Yeah.
With the fox over jumps over the justified text problem. So.
Exactly. It just says I don't know what exists beyond here. Let me just start this and see where it goes. And it's like, okay. And all I did, it was very systematic, right? All I did was like, what's the worst thing that can happen? Oh, well, what happens if the machine fails? Can I restart my job? Okay, I need to have some way to orchestrate that. And then I just said, okay, well, what's it going to take for me to handle that job? Oh, yeah, well, let me just write it to a database. Oh, what's that database going to have? These fields. What's the database? What else does it need? It needs a job ID, and this is what's going to allow it to go to restart the job it needs. And then, okay, well, can I scale this out in case multiple machines fail? Like, oh, yeah. And I was like, well, what does it take for me to do that? Just record this. And it's like, okay, well, what happens if my database fails? Oh, I have replication. And how much replication can I do? Oh, here's this back to the math envelope calculation. All I do is just approximate each one of these shit. Right?
Okay. A problem I see when I do these problems, like when you say, like, how are you gonna make sure? What are you gonna do if the job fails, right?
Yeah.
I think my mind like kind of blows up and it starts thinking too complex, man. Yeah. So that's something I'm gonna work on this weekend.
Yeah.
Because as I was doing this problem, like I was thinking of all these scenarios, and they were just too complicated, and it just confused me more. So.
Yeah, just start very simple, like and organize them into like very, very simple categories, right? So for instance, what happens we should go back to the problem I just did, right? What happens if the machine fails? Oh, I should be able to get that from disk and restart that job. What's it going to take to do that? Okay, here's the things, because like if the machine fails, my only two choices are for the user to manually restart it or for me to restart it automatically. Those are the only two choices. It's either manual or automatic. And automatic is the most obvious choice, right? And so I said, what's it going to take to do that? Okay, what's the least amount of effort to do that, right? It doesn't really get that too much simpler. Like, the machine can fail for 10,000 reasons, but it's all going to lead to the exact same way of handling it. Get the fucking info back from the database. And then once I know that's bulletproof, go to the next one. Like, oh yeah, what happens if the database fails? Oh, replication. Let me just put it in, like, it could be the same data center, it could be a different data center. I don't care. It's like, okay, well, these machines. Back the envelope calculation says I can do 2,000 machines. I think that's way more than the single user needs for what he needs, right?
Yeah.
Eventually, I'll revisit the question when my users reach like 2,000 or like 200,000
Yeah.
jobs per second or whatever fucking number comes along. But for now, it's good. It's good enough.
Yeah, yeah, but you can also argue like you're not gonna have like 1,000 devs on a single team, right? Or
Yep.
pushing to one branch, right? So
Eventually, we'll get there, right? But it's about
Mhm.
building it from the ground up and just going systematically through it. And it's something we talked about, right? Start with something simple. What's the worst thing that can happen? What's the inefficiency? And run a user through it, or run through some worst case scenarios or disaster scenarios, and then try to
Mhm.
bulletproof it.
okay, okay.
That's really all this. Like, I didn't really deviate from that, actually. If you notice, is like, look,
Yeah, yeah.
I'm sure like you say, oh my god, like how's he doing? It's like it's really just that simple. Just take something simple, run it through a few scenarios, fix those scenarios, then scale when you are comfortable with the amount of bulletproofing that you've did.
Mhm, mhm. I see.
That's it.
Okay,
All right, that's it for me. Any final thoughts?
cool. No, I'm good.
All right, yeah, just keep practicing. I think that's really all I can suggest. Is that when it doesn't seem like the ideas are hitting you, dun 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 dun, like that means that there's some framework that needs in your head that needs to be updated. It should be smooth like music. So I think that's gonna be the key for this weekend.
I see.
Make music, make it smooth, make it so that way it's fluid. Be like water, like Bruce Lee.
Mhm, mhm.
All right, I'll see
I
you
see.
later.
Okay, cool, cool. That makes sense. Okay, okay.
All right, yeah,
Cool.
see you later, man.
All right, thanks.
All right, bye. Okay. Any final thoughts from the crowd? Hi, Elliot. Hi, Crow. Do I have any vacancies at the moment? No. So I have this policy where if I have clients that are waiting, I have my hands full with C. Yeah, I kind of have my hands full with C. We're trying to make the last 2 weeks, and then I think I asked him to schedule his interview on the 15th. He basically has 2 weeks to try and make all this smooth. And I don't know if he's gonna make that. At this point, it's just his instinct and whether or not he can make music out of it, right? And I have this policy where it's like if I have like one or two clients that haven't quite made it yet, I don't really want to take on other people. I owe it to everyone who trusts me to give them my best, and I feel like I can't do that if I take more than two people on. That's the thing. I have a full-time job, and then on top, and I have everything else going on in my life, and then I read investment papers. So really, I can only take on two clients at once. And the only reason I'm doing the take on the second one is because Jay's loop is really, really just taking a long ass time. So it's like, okay, I can just keep that on the back burner, and when it pops up again, we'll deal with it, right? So if I was anyone else or I could hire other people to do it, I could do it. But I don't think any of my past clients who have immense success that I would consider subcontract this to would have a interest in taking on other people. So unfortunately, and plus, like if you think about the timing, right? Let's say I started with you right now. Then your interview would be in winter shutdown, like December 18th or January 1st. So the timing kind of gets fucked right there, right? And so, because like that during that week, there's really nobody to take on your interview. We experienced that with Russell last year, where we barely made like the December 11th, I think, interview, and he didn't hear back for like 6 weeks, 6 to 8 weeks, and it was like a real fucking stressor for me. And I learned from that: get the feedback as soon as possible, and then try to work with that. You want the turnover to be fast enough, but not fast that you get sloppy. So, it's I don't like taking on clients towards this December. I think is the lesson here. I'll open it back up in January once we hear back for C's results and J's results. Once we get Jay in an actual job. So, but yeah, I think I'll stream while I'm in New York. I think that if people want me to just stream and chat and talk about engineering and stuff, send me some topics in Discord, and I'll try and I think if they're good talks, I'll make a talk. I'll make a stream out of it. So with that, thank you all for joining me. My voice needs a rest after 2 days of of work events. So follow me on Discord. My socials are in the description down below. Other than that, I'll see you back here next Tuesday, 8 p.m. Pacific Standard Time. Thank you all, and have a good night.